Okay, good afternoon. So today we're just going to wrap up the grade 12 paper 1. So at this point we have answered the first or most of the paper at this point. We've answered up until question 5. Okay, all of question 5 we have answered. So now we're looking at question 6. Question 6 is in 6.1. If f of x equal to x squared minus 2x, determine f prime x from first principle. F dash x from first principle. Alright, so the first principle is the definite question in your exam. So it's normally 5 marks, 5 or 6 marks. You have in the form. So it follows the formula f prime x equals the limit as x approaches, or h approaches 0, sorry. The limit as h approaches 0 of f of x plus h minus f of x all over h. This formula is also on your formula sheet. So if f of x is equal to x squared minus 2x, then f of x plus h is going to give you x plus h squared minus 2 into x plus h. Okay. So I'm going to fill that in. It's going to be the limit as h approaches 0. I'm going to simplify it one time. So it's x squared plus 2xh plus h squared minus 2x minus 2h minus open brackets x squared minus 2x all over h. And simplify. So it's going to be the limit as h approaches 0. X squared cancels x squared. And that's going to give you positive 2x, cancels negative 2x. So as you can see here, we are left with 2xh plus h squared minus 2h. So I take out h as a common factor. I'm left with 2x minus, or plus h minus 2 all over h. The h is cancelled, we erase the h and the 0 thereafter. Drop the limit, so 2x is equal to, and f prime x is simply equal to 2x minus 2. Okay. In 6.2, we are told determine dy dx. Okay. The derivative of y with respect to x. Yes. So alright. So the derivative of y with respect to x. So 6.2.1, that is in the form of ax to the exponent n. Once it's in that form, I can apply the derivative. So this would give us dy over dx. The derivative of y with respect to x equal to 12x to the 11 plus 12. Let's look at 6.2.2. Here we're going to put each one of its own. So y is equal to 5 over x squared. You must first get it in that form. Okay. Plus the square root of x, which can be written as x to the exponent of half over x squared. I'm going to simplify, bring that up in both cases. So y is equal to 5x minus 2 plus x, a half minus 2 is negative 3 over 2. So dy over dx equals negative 10x minus 3 over 2x minus 5 over 2. Remember that the exponent gets multiplied by the coefficient and a minus 1. Okay. And I've indicated the change there with the dy dx. Okay. In question 7, make this a bit smaller. Bring that down. In question 7, we are told sketches the graph of f of x equals x cubed minus 4x squared minus 11x plus 3. A and B are turning points of f. Determine the coordinates of A and B. So how do you work out the turning point? First derivative. Set it equal to 0. So f prime x equals 3x squared minus 8x minus 11. Set it equal to 0. So x works out to be 1 of 2. I can either use the quadratic formula or my information of factorizing a trinomial. My knowledge of information. So it's going to be 11 over 3 as well as negative 1. Okay? Why are there 2 points? Because there are 2 turning points. Okay? So at this point already we know that b is going to be 11 over 3 and some y value, and x is going to be negative 1 and some y value. So what we then do is we say, okay, let's click away from here. We substitute that x value into the function. We'll get the corresponding y value. And we then do the same for negative 1. Okay? So we say, okay, it's 11 over 3. 11 over 3. Alright, so that's going to be answer cubed minus 4 answer squared minus 11 answer plus 30 as the last answer calculated in the calculator. Going to give you negative 400 over 27. So this point here is negative 400 over 27. The corresponding y value here. The other one, remember that is now, sorry, is at the wrong place. This is actually negative 400 over 27. Negative 1 gives us 36. Okay. So your coordinates of A is negative 1 and 36, and B 11 over 3, negative 400 over 27. Okay. So let's see what's the next question. The next question says, let's pull this up. Okay, so question, what I'm going to do is I'm going to remove this here so that we can have space to write. Okay. Move this down a bit. Okay, in 7.2 the question says for which value or values of x is f decreasing. So as you can see here, as x increases, the value of y increases. So that's this part of the graph is increased. So the graph is decreasing from an x value of minus 1 all the way to 11 over 3, and then the graph is increasing again. Alright, so it's a continuous solution between 11 over 3 and negative 1 and 11 over 3. So that will be written together. So 7.2, x has to be greater than negative 1 but less than 11 over 3. In question 7.3, we are told, let's take this one out. Determine the equation of the tangent, the graph at x equal to 1. Determine the equation of the tangent to the graph at x equal to 1. So what we do is, we work out what f of 1 is. So we put 1 through the formula to get the corresponding y value. We get 16. So that point is 1 and 16. So that point is approximately here. Okay, that's somewhere there. Okay, 1 and 16. Then, so that's the point of contact. Okay. So if I draw the graph, it's going to look something like that. The tangent, it's going to touch at that point only. Okay. So from there we can see we're going to have a negative tangent and a high y-intercept higher than 16 at least. Okay. So what we're going to do is we find f prime of 1, which is also my gradient of this graph, of the tangent. Okay, so that's going to be 3 times 1 squared minus 4 times 1 minus 11. So put that in the calculator. 3 times 1 squared minus 4 times 1 minus 11. You could have just said 3 minus 4, which is negative 1, so you get negative 12. So we have a gradient of negative 12, a very steep gradient. So the equation of this line of the tangent is y is equal to negative 12x plus c. Remember, that's your gradient of the graph. What is the first derivative? What is derivative? The first derivative? The first derivative is the general gradient anywhere along the curve. By substituting the x value in, I get the gradient at that value. So we're going to substitute 1 and 16. Remembering that's the x and a 1. Okay. So 16 is equal to negative 12 times 1 plus c. So c works out to be 28. So y is equal to negative 12x plus 28. Alright? Okay, I made a mistake. Okay. The derivative, I tried doing this out of my head. So the derivative is going to be 3x squared minus 8x minus 11, and I wrote 4. That's my mistake. Thought this one doesn't feel right. Let's go again. So that should give us an answer of 3 minus 5 is minus 16. Okay? Which is the gradient of this graph. So we have y is equal to negative 16x plus c. At this point we substitute 1 and 16. We substitute 1 and 16. So it's going to give you 16 is equal to negative 16 times 1 plus c. So c works out to be 32. So y is equal to negative 16x plus 32. Yeah, that rings a bell. So y is equal to negative 16x plus 32. My mistake was I did this in my head and I didn't multiply the 2 by the 4. Okay? So let's look at 7.3. We first make again space faster, right? 7.4. In question 7.4, we are told hence determine the x coordinate of the point at which the tangent cuts the graph of f again. So what happens is, it's in the draw it here. So if you had drawn a tangent here, okay, that's a tangent at that point, but somewhere or other later on, the graph will cut again. Okay, so we are calculating this point now, because that's a point of contact. We're calculating that other point. So how do we work out points of intersection? We basically set the two graphs equal to each other. We set the two graphs equal to each other for the points of intersection. So the equation of f of x is x cubed minus 4x squared minus 11x plus 30, and is equal to the equation of the tangent, which is negative 16x plus 32. Alright. Now that's probably behind the camera on that side. So I'll work more on the side here. So x cubed, I'm solving for x. I will have x on one side, everything on one side and 0 on the other. So you can use the factor theorem rule there. So it's x cubed minus 4x squared plus 5x minus 2 is equal to 0. Okay. Right. So we know that x plus 1 is going to be a factor. X minus 1, sorry. Because at this point, the graph is going through there as well. Okay. So it's going to be x minus 1 is a factor. So that will give us x squared plus 2. That's going to give you negative x squared Negative x squared plus what's going to give me negative 4x squared, negative 3x squared. And of course that can be factorized. X minus 1, x minus 2, x minus 1 equals 0. So x minus 1 squared, that's a 2-in-1 solution here. As we know, that is where the tangent occurs. And the other one, the other x value they're looking for is x is equal to 2. So if I should have drawn this graph in, this graph will look something like that. Okay, it will go through there and that point. Okay. The tangent, no? We'll cut those 2 points. So the point that I'm looking for is x is equal to 2 there. Alright. Let's look at number 5, 7.5, 7.6 epsilon. In question 7.5, the question says determine the value or the values of k for which this equation here, if you look at x cubed minus 4x squared minus 11x plus 30, this part is actually the f of x graph. They could have asked you the same question, but they could have said, where's f of x equal to k? They could have done the same. Alright. So, just take this out here. F of x equal to k. So, if they say as one root, the roots are basically x-intercepts. Alright, so if you look at this graph here, just draw a line in here. It's okay. This is your x-axis. Alright? So how many roots does the x-axis have at this point here? You all should agree 3. There are 3 roots. There's 1 here, 2, 3 roots. The roots are where it cuts the x-axis. So it's 3 there. Okay. If I take that line up a bit, let's pick up the line.
Good morning.
There's 3.
All teachers who haven't completed their special invites can please buzz the office or contact the office. All those teachers who still haven't completed their special invites can please contact the office.
Okay, so as long as it's between these 2 turning points here, it's going to cut thrice. Okay, anywhere along the graph, it's going to cut twice. At the turning point there, it's going to cut twice. At the turning point once and at this point there. So it's 1, 2, it's twice. Anywhere above that, it's going to cut once. As you can see, this graph carries on here, so it will cut it at that point only. Okay? So in other words, if you're going to see where it's going to cut once, it's any value more than this current y value here, which is 36. So in other words, k, this is 7.5, k must be greater than 36. Or, look at the side here, it cuts thrice, 3 times, 3 times, 3. At this point, here is twice. Anything lower than that, it will cut once. So it will be cut once for k is less than negative 400 over 27. Okay? That's that question. Then in 7.6, they want to know, determine the x-coordinate of the point of inflection of. So before I go into that, I need to know what the point of inflection of this graph is, of f of x. So the point of inflection, we apply the second derivative. So f double prime of x equals, so that will give us 6x minus 8. I say that equal to 0. So x equal to 4 over 3. So the point of inflection is at 4 over 3, which is approximately here. The x value of 4 over 3. Okay. The question says, you must determine the x-coordinate of the point of inflection of p of x, if p of x equal to f of x minus 3. So what effect does minus 3 have on this graph? The graph is going to shift, shift 3 units, 3 units, oops, 3 units to the right. It's always the additive inverse effect, okay, on the x. So it moves 3 units to the right. So if I move 3 units to the right, this also moves 3 units to the right. So therefore the point of inflection the x coordinate of the point inflection for the graph of p, with the function p, is going to be 9 30 over 3, or 4 and a third. Okay. Alright, let's carry on with our lives. Okay, so that brings us to the bonus question. Okay, the end of the year you're not going to get the bonus question. So make full use of this here. So my question was, in the diagram below, the shaded region is bounded by the graph y is equal to x, y is equal to 4x, which is this graph here, and x equal to a, which is this line here, and the x-axis, which is this line. You see this? The shaded region is bounded by that. Okay. First question is, the area of the shaded region is. So how do you calculate the area of a triangle? We know the area is equal to half base times perpendicular. So it's half, my base here, the base is from there to there, we know that's 0 there. So it's going to be a times your perpendicular height, which is this length. We know that this point here is an x value of a. The y value is what I'm interested in. If I substitute a in there, I'm going to get 4a. If I substitute it here, which makes the height of this triangle 4a. Okay? So that's simply half times that gives you 2. So the answer is 2a squared. It makes the answer B. Alright. That's fairly simple. 2 marks. And the last question, 8.2 says, the expression negative 2 plus the square root of 2 minus x is not a real number. The expression is not a real number for all values of x such that. So this will be non-real if under the root is negative. So in other words, it's where 2 minus x has to be less than 0. They get over the equal sign. So negative x is less than negative 2 divided by negative x has to be greater than 2. Which makes the answer A. Okay. That basically brings us to the end of this paper. Okay. I'll start paper 2 now.